Alright, so this is the tutorial video for homework 2, problem number 3. And just to reiterate what I was saying in the previous video, we should not have the same answers on that one since I didn't do the filter for males over the age of 18. So I just wanted to make that clear again. On this one I will be using the same data set that you all will be using and following it pretty closely. So alright, let's get started. So it's asking to predict the sales based on the size of the store. So let's go ahead and pull this up. Just a few notes about this data set. The annual sales are in millions as stated in the directions, and square feet are shown in thousands, so that's something to keep in mind. So first we are going to give an estimated model of predicting sales based on store size. So we're going to go to Analyze, Fit Model. We're going to put square feet on X, annual sales, our dependent variable, on Y. Our emphasis is a minimal report, so we're going to run that report. And this is what it returns. So our estimated model is down here at parameter estimates. You're going to be using these two figures right here, and let me show how to type that out. So as mentioned, we have sales in millions of dollars, and this would be shown as sales equals 1.559, that's 1,000, times square feet plus your intercept 0.904, and as I mentioned, that's coming from right here. And then right after that, for B, we're going to give an interpretation of these coefficients. So what this is saying is for every 1,000 square feet increase in the size of the building, there will be a $1.559 million increase in sales. So that is how you interpret these coefficients for this equation. And also, we probably want to go ahead and show an impractical interpretation, and that's if the building has 0 square feet, then the sales would be $0.904 million. So that's how you'd interpret this equation, and that would be B. Alright, so for C, it's asking how well does the model fit. It's asking for your correlation coefficient, which isn't shown right here, but if you wanted to in Excel or on your calculator, you could just do, since this right here is R square, if you want to just do the square root of that, 0.910066. You can do that. You get 0.953974, so pretty much 0.954. And then I'm sure Dr. Shiflett has shown this, but I'll show you another way to find R, the correlation coefficient between two variables, and you just bring both of these over here and do OK, and then it gives you R right there, your relationship between the two. Okay, and then it asks for R square, and that's just right there for you. That's that 0.91 number. Your statistical test of slope is, for that, you go down here, parameter estimates, and what you want to show is for square feet, you want to show the t ratio and the probability, your p-value, probability greater than your t ratio. So both of these are just signifying that the slope is indeed statistically different than 0, or different from 0. So if this were quite a bit higher, then that would be an issue. Okay. So for D, give the four assumptions made, and then it asks how well are these assumptions met. So before we do this, we're gonna go up here to response annual sales, this red triangle, save columns. We're gonna save residuals, which is what we need for this, and then let me show you how that kind of works. So once I did that, once I click save column residuals, it automatically goes straight to the data set. And whoops, for later on in this problem, we're going to go ahead and save 2 more columns, and that's studentized residuals and hats. But okay, so for these 4 assumptions, we need to just use the residuals. So first we are going to go back into Graph Builder, put residual annual sales on Y, and then square feet on X. We're going to remove this squiggly line. And what you're looking for here is, in this case, you do not want any patterns to be seen. So when you have this scatter plot, you're checking for linearity, equivariance, and independence. And it looks like none of the points are really dependent on one another. If that were the case, they would be forming a pattern in one way or another. It could be in the negative direction, straight horizontal, or straight up and down, or in the positive direction. So equivariance is okay. Linearity is okay because there is no linearity. And then equivariance seems to be, except for maybe a few like tiny clusters, there seems to be pretty equal variability. So those 3 assumptions are okay. Then to check the normal distribution of the residuals, you want to go into Analyze, Distribution, Residuals. It's going to return a histogram, so hopefully this is a little bit familiar. Then we're going to stack that, and you're checking to see the distribution of the residuals. And as you can see, this is pretty normal. Fairly normal distribution, so I would note that in your answer on the homework. All right, and then okay, use the model to estimate the sales of a 2,800 square foot building. So we're just going to go back to our formula right here, and you just do equals 1.559 times, you're going to do 2.8 because it's 2.8 thousand, then plus 0.904. Let's put this in parentheses just to make sure. So what I did there is I just plugged that 2.8 thousand square feet into the formula right there, and it'll return a value in millions of dollars in sales. So it says if we have a 2.8 or a 2,800 square foot building, that it estimates that it would bring about $5.27 million. So they're wanting to generate at least $6 million in sales. So this would be an inadequate store size. Alright, and then for F, we're going to check for outliers and high influence points. So this is why I had you all save the columns, studentized residuals, and the H values. So we're going to go back here, and really for this one, for this homework set, you can kind of just peek through studentized residuals. What you're looking for, in order for it to be an outlier, you're looking through studentized residuals, and these values must be outside of -3 and 3. So if it's within -3 and 3, then it's okay. But if it's, say it's -3.5 or it's 3.2, then it would be considered an outlier. But say you have, instead of just 31 observations, say you have about 500. So I'm going to show you, you go to row selection, select where studentized residual sales is less than -3, and Hit OK, and there are none. If there were, it'd say selected, and there'd be like a bolded row. So you would do that, you do less than -3, and then you do the same thing for greater than 3. And if there's anything outside of that, then it'd be considered an outlier. For high influence points, you have to do a formula. So it's 2, let me double check on this, 2 times k plus 1 divided by n. K is your number of independent variables, and n is the number of observations. So in this case, sales is your dependent variable, and store size in square feet is the independent variable. So we have one independent variable. There will be sometimes whenever you have 3 or 4 independent variables, and that's your k value, and n for us is 31 right here. So we're just going to plug those in. So it's 2 times 2 divided by 31, and it returns this value that really doesn't have a unit behind it, so it's kind of just a threshold. So if h exceeds this, if any hat values exceed 0.129, then it's considered a high influence point. So row selection, select where h values greater than 0.129032. Okay, alright, and then it shows one selected right there. So that's kind of a good example of that tool being used. And if you scroll on over, you see that it is indeed greater than 0.129. So that is a high influence point, which just means that it's an extreme data point in the X direction. So I think that just about covers everything. So hopefully this was helpful, and I think we're doing a little bit better on time. Just remember to make sure you're copying and pasting your output onto a Word document for your homework, and adding also some text just explaining, answering what she's looking for, and kind of explaining your output a little bit. So yeah, thank you very much, and I'll be making another video for the third homework. Have a nice day.